Good morning, students.
Good morning, ma'am.
Good morning. Did you all do that? Somebody's this is on speaker. Or is it my oh yeah. Or I did not understand what we discussed in script arithmetic problem. All right, we started game playing. Here, we let us understand the terminology of the participants of game. There are two players. The players are Max and Min. Does anyone know why we have named them as Max and Min? Whoever it may be, whether it is human or computer, the one who plays in order to maximize his benefit and increase his reward, that is Max player. Min player is the opponent of Max. The one who tries to uh, win and make Max reward lesser or points lesser. If suppose Max is getting 8 points and 5 points, there are two options. Min player chooses 5 in order to reduce the points of Max player. So Max is the one who is trying to gain more rewards, and Min is the one who is trying to decrease or reduce the rewards of the Max. Means they are playing in opposite direction. Min is opponent to Max. So these are two players, max and min player. Um, Apparently, Max is trying to minimize his own game. At the same time, Max is trying to maximize his game, at the same time minimizing the opponent's game. Opponent is
Excuse
me.
me, ma'am.
Yes.
Ma'am, did you sharing screen?
Oh, thank you. All right, max and min players. I hope it's clear. What is a game tree? Another terminology is game tree. It is a representation of all possible moves of the game. We already looked at that 8 puzzle problem game and how we can shift the that empty space, shifting the empty space up, down, left, right. This we could do, and we get different configurations. That is representation of the move. And a game tree is a tree that represents all the plays or the moves of the game. From here, what are the moves? And from here, what are the moves? Like this, it will list out every move. That is a game tree. We already looked at the outcomes of the game, which are three. There are three outcomes. First one is win, second is loss, third is draw. Here, please understand that tree would have terminal and non-terminal nodes. If this is the game tree, the last layer are the terminal nodes and all the other are non-terminal nodes. There are two cases to consider here. In case J, which is a non-terminal max node, J, non-terminal max node, the status of J is it wins if any of J's successor is a win. Consider this to be J. J wins if any of the successors. How many successors it has? 1, 2, and further down the line is 4. If any one of the successor is a win, J is a win. Loss, if all the J successors are loss. We are talking about max node here. This is a max node. J. J will win if any one of its successor wins. J loses if all of its successor lose. And there is a draw if J successor is a draw and none is a win. If any of the J successor is draw and all the other successors are loss and not a win, then there is a draw. Second, if J is non-terminal node, which is of min kind, consider here. Uh, this is a min node which is non-terminal. The status of J is determined by going through its successors. It can be win, it can loss, it can draw. When it wins if all J's successor win. Here, what is the case? If any one of the successor wins, max node J non-terminal wins. Here, if all wins, then min node will win. And if any one successor of J's node is a loss, then it is loss for the J node. Draw, if any successor is draw and there is no loss, none loss. What is this? If any successor wins, it wins. If all successor lose, it lose. And if any successor has draw and none is win. Please remember these criteria for determining the win or loss or draw status of a node, which are non-terminal, relevant to max and min. Let us be back to NIM game. We have learned that NIM game was developed by Charles L. Boughton at Harvard University in 1901. And in this game, there is a pile of matchsticks, and there are two players. Moves are made by the players alternately, and each player can pick up maximum of half of the matchsticks in a pile. And whoever takes the last matchstick loses. This is NIM game. Let us start playing the NIM game and understand how it works. Here, which tree is suitable for gaming? DFS or BFS? This is a question to all the students. Anyone could answer. Which tree is suitable for games? Not only NIM, for any kind of game, DFS or BFS. Based on the operation of the tree, please tell me which one is more suitable. Please try, students. Just try to recall the working of DFS and BFS. Okay, anyone please tell me the working of DFS? How does DFS works? Root, first leftmost child, its leftmost child, and so on until it encounters terminal node. After terminal node, it backtracks to its parent, and if there are any children or a child, go to that, backtracks to the parent. If there is any child or if there is none, backtrack to the parent. This is how DFS operates. How does BFS operates? Take one node, generate all its children or subnodes, and take one, generate all. This is level ordered BFS. For gaming, which tree is more suitable? Depth first or breadth first? Students, are you all there? At least in chat window you respond something, you give answer. BFS. Why BFS? If one answer come out, we can discuss it in detail and then try to understand the reason behind choosing an option out of the given options. When you are playing chess, how do you play chess game? uh, Consider you begin. Max begins. Max takes its move. Then next, suppose we are building a tree. Next, who should play? Min should play. Min. Then who should play? Max should play. Then Min should play, and so on until the end. And it looks like DFS or BFS.
DFS, ma'am.
It looks, yeah, it looks like DFS.
Yeah.
For gaming, DFS is more suitable. Why DFS is more suitable? Because it is alternate turns, and uh, in order to represent and visualize all the moves, what we can do, we can put in this manner. In the second cycle, we can say that Max could also take this path instead of this, and Max could also take this path and this one. There are so many moves Max can take. To begin with, he can take only one move. He is allowed to take only one move. So this is only one option out of several options. uh, or he can go for second option, or he can go for fourth option. It is his wish. Max, whatever Max decides here, let us consider Max to be computer, and the goal here is to develop a strategy such that the computer wins. That is the goal. Develop intelligent programs that could play games with humans and wins. For that purpose, consider Max to be computer, Min to be human. And what is Max goal? Maximize his reward and minimize the opponent's reward. That is the goal of Max. And what is the goal of Min? Min's goal is to minimize the Max reward. With these motives, they play. And when you represent the tree, you can write all the options. This is a full game tree. In full game tree, you represent all the moves that are possible from the start state. And Max can choose any one. Consider that this game is game X, has these options, and Max chooses this option, second one. And then next one is Min's turn. Consider that uh, from here there are so many options for Min. From here there are so many options for Min. Likewise, every option could lead to several options for Min. Min would choose because Max has chosen this. We have control only on our move, not on the move of the opponent. We cannot tell to our opponent take this move only. So out of the several possible alternatives, the opponent can choose any one. But what should be our strategy? Whatever move opponent chooses, we should somehow try and win and make the opponent lose. When you consider the example of tic-tac-toe, Max is a system. How many option system has here? System has here 9 options, 9 choices. So from here we get 9 successes. There are 9 successes. But out of these 9, Max can play only one. And typically when whoever begins, they chooses the center one. So Max has chosen to fill in the center. What Min would do here, Min choice would be, Min would yeah, Min has 8 options. 8 options. So Min can put a knot anywhere. If Min has put the option here, then again Max would what Max is trying? Max is trying somehow to form all crosses in one row, column, or diagonally. Max might put here. Now, what is the option left for Min? Actually, Min can choose 1, 2, 3, 4, 5, 6. There are 6 choices. But which choice Min would take? Which one?
It will not allow the crosses to form a diagonal line, ma'am.
Yeah, diagonally. Here, Min will place its knot. It will not allow the Max to win. If Min uh, places a knot at this point, this point, this point, or this point, or this point, there is a possibility, or not possibility, well, it is like for sure uh, Max would win. Here, if it is empty, if this slot is kept empty, Max would win. So Min would not allow that. Min would put a knot at this point. So this is how game playing proceeds. Consider the NIM game. There are 7 matchsticks. So we have a pile of matchsticks which are 7 in number. What is the rule here? The rule is that any player could choose maximum half of the matchsticks, not more than that, half or less. So here, what are the options? What are the options? Will anyone tell me what are the options? This is Max player, Min player. Alternately, they play Max, Min. So Max has how many options? How many choices based on the condition? Max can pick up one matchstick. Max can pick up 2 matchsticks. Max can pick up 3 matchsticks. out of 7, not more than 3, because this one is an odd number. uh, it would come, half is 3.5. Instead of 3.5, 3 can be chosen. So any one choice max could take, 1, 2 or 3. If max chooses 1, how many would be left in the pile? 6 would be left. If max chooses 2, this pile would comprises of 5 now. Why 5? Because 2 has been chosen by max. So pile would have only 5. Here it would be 4. Uh, Students, please note that here I am drawing the complete game tree. In reality, uh, any one choice max takes, and any one choice min would take, and the final result outcome is obtained based on that. But let us see what are the total options available. Max can choose 1, 2 or 3. If max chooses 1, out of this 7 matchsticks, if 1 is chosen, 6 would be remaining. See, here it is 6. If 2 are chosen, 5 would be remaining. If 3 are chosen, 4 would be remaining. Out of 6, now what are the options for min? Would anyone tell what are the options for min?
Up to 3, ma'am.
Up to 3. Min can choose 1, 2, 3. Out of 5,
2.
what are the options?
Yeah, ma'am.
Only 2 options. So for 5, 5 could be, because here 2 is already there, we can just use that instead of writing 2 again here. 5, 1 and 2. And no, wait, someday, some problem here. 5 could choose 1. When 5 chooses 1 and 6 chooses 2, leftover would be 4. Okay, for this purpose. If min take 2 matchsticks from the pile, out of 6, 4 will be left over. If 5 chooses 1, even in that case 4 would be left over. So it's not exactly pointing to 2. It is, we will write separately. When 6 chooses, means if 2 are chosen, 4. If 1 are chosen, 4. Here if 1 is chosen, 5. Here if 4 and here one more option is there. This is 3. 3 means here 3. Here also, if 2 are chosen, 3. 3 will be left if 2 are chosen, and 3 would be left if 3 are chosen from 6. And for 4 also there are two options, 1 and 2. If 1 means here this one, if 1 is picked up, if one matchstick is picked up out of 4, 3 will be left over. If 2 picked up means 2 will be left over, so there are no 2, so 2 will write here. So for max, these are the uh, number of leftover matchsticks. In case here, remember, we are traversing the entire tree. After we place the entire tree representation, we will see how it can play, okay, one particular move. Now you please try to learn how to develop a representation or a game tree. This is how a game tree is developed. From 5, Max would have two options. Max could take 1 or 2. If Max takes 1, 4 will be left. If Max takes 2, 2 will be left. No, 3 will be left. From 4, if 1 is picked, 3 will be left. From 4, if 2 is picked, then 2 will be left. From 3, if 1 is picked, 2 is left. From 2, if 1 is picked, um, this is, if from 2, if 1 is picked, 1 is left. Okay, so 4, 3, 2, 1 we get. Next it is Min's turn. Min, what Min could do? Out of 4, Min would have two options. It can pick 1 or 2. If it picks 1, 3 will be left. If it picks 2, 2 will be left. From 3, if 1 is picked, 2 will be left. From 2, if 1 is picked, 1 will be left. This one, it could be win or lose. That we will see. And whoever gets the last matchstick loses. And now it is Max turn. Max have 3 out of 3 um, values. If he chooses first one 3, from 3 he can pick 1. If he picks 1, then 2 will be left. And if he picks 1, no, this is, if he picks 1, if he picks 1, 1 will be left. Here we have to decide whether it wins or loses. This is Min. Min Min can pick 1, 1 will be left. This also we have to decide, and this is Max. Okay, this is the complete game tree. Complete game tree when Max plays first. If Max plays first, from the pile of 7 matchsticks, let us determine the win and the lose. From 7, if he picks, Max picks 1 this way. And from 6, if min picks 1, and max, if max chooses again 1, if min chooses 1 again, means this is one game. If max chooses 1 again, if min chooses 1 again, then who has lost? It is whose loss? This is L. Max has lost. Because when min has, out of two matchsticks, if min picks one will be left over, and whoever gets the last matchstick is the loser. It loses the game. When we play in this manner, computer, consider computer to be max chooses 1 out of 7, only one matchstick. Left over are 6. If min also chooses 1, left over are 5. And if max also chooses 1, like this, if on their turns, if they pick 1 1 alternately on each of their turn, it turns out that max loses this game. All right. And here, what are the rules? This 2 is a non-terminal. Students, are you all with me? This 2 is non-terminal. What are terminals here? Terminals are this one, this is terminal, this one is terminal, this one is terminal, this one is terminal, this one is terminal. Terminal means the last one, the leaf node, to which there are no successors. And all the others are non-terminals. When max loses, what is the status of min? To determine the status of min node, which is this one 2, we need to consider the rules. We already learned the rules. If it is a non-terminal and min node, it loses if any one of its successor lose. It wins only when all its successor wins. And there is a draw if there is any one node with draw and there are no nodes with the loss. This is how you have to assign the status, win or lose. Here, this is also L. At here, it is L. Why it is L here? It is L here because here it is L. Because its successor is L. And what is there for max? What are max successor? Only one successor, and it is L. Therefore, this is also L. And what is this min? Min has got two successors. We don't know what is the status of 2. So let us check up on the other path. What happens? When you take this route again, 7, out from 7 max will pick 1. Then from 6 min would pick 1. Then from 5, Max would pick 2. If Max picks 2, then we are going to this path. For Min, 3 will be left. If Max picks 2 out of 5, 3 will be left over. Min would have to choose from 3. And then here, from here, there are no options. Here Min can pick only 1 and Max could pick only 1. And then now who is winning and who is losing?
Minimum will lose.
So here, one point please understand. We are playing with respect to Max. We are playing with respect to Max. Because we are playing with respect to Max, what happened is, if Max gets last matchstick, Max loses. If Min gets, Min wins. It is the opposite. Because we are playing with respect to Max. Because we are playing with respect to Max, if Max gets 1, Max loses. Whereas here, Min is getting 1, so Min will win. And here, because there is a win for this Max, here Max would win. Actually, Min loses only. But then, because we are playing with respect to Max, if we put here L, here Max would get L at this non-terminal node. That's why here we put W. If we put W, here Max would get W. Otherwise, Max would get L. But Max is winning with respect to this second non-terminal node. And because this is a win, here also it is a win. Because this is win, here also it is a win. And here it was loss. This 4 was loss. Loss win will be win for Max. Loss win will be loss for Min. Students, when you do this, you will understand. Don't worry if you don't understand. Anyway, tomorrow we have class. Tomorrow we will discuss again. What you all do now, create a complete game tree for Min, in which Min plays first. And then what you are supposed to do is, you are supposed to label every node with either win or lose. Then you will understand. If not, then I am here only. We will be here in the class. You stay, don't leave. And try to create a game tree for NIM, in which Min plays first. For the same thing, here Max is playing first. You change this to Min and tell me what happens. Please start. Students, one more point here I would like to add. Eventually, you have to determine whether max player has won or lost, whether there is a win or a lose for a max player. When you label every node with either L or W, finally you will get here L or W. Let us, okay, you complete that at home. Let us finish this. But did you understand that point? If max gets last, it is L, you have to label. If min gets, you have to label it W. And here it is min, so it will be W. This max would be W. This min would be W. No, W or L we have to determine here. Let us do this first, then we will understand. Here max is L. This is L for max, this one. For min, this is L. This is L, LW, LWL, then LWLW. Then here it is W because this is max and any one W means W. And this one is 4 is W because any one W is W for max. And this one is L. Uh, this for 3 it is L because uh, this 2 is L. 3 is leading to 2, 2 is L, so 3 is L. And W, 2 is W, okay. And here this 6 is min. Min, it is going to 5, 4 and 3. There is one L, so 6 would get L. 5, there is W, L, because it is min, it is L. If any one L is there in the successor, the parent would also get L. And 4 is min L. And max, here max loses. Yeah, na? Here from here we know that max loses, and eventually also if you label it and then determine, then also we know that max is losing. Now you do for min. Continue and tell me whether min here would get W or L, whether min would lose or win. Anyone got? Let us also do. Let me do here. This is min. Okay, students, you please uh, write and make PDF and send me.
Okay, ma'am.